So I can also assign Campbell message measure for the non-stationary mark point process. So what will be different here is the mark distribution because that will depend on the location x. So here I will have this new xk, which is the probability that the mark of a point at x belongs to k, condition that there is a point at x. This conditioning is always inherent because without a point at x, we cannot define the mark at x. So for such point process, the underlying intensity measure is lambda A. C A cross K is equal to expectation over summation over indicator that point belongs to A and the mark belongs to K. Here I do the same thing. First condition on n and compute the expectation with respect to condition given n, and then I decondition with respect to n. So once I have this and conditioning, this become deterministic. So I pull the summation outside. Rest term is a function of points and mi's. So I condition on xi, right? So for every I'll condition on a different point. So here I'm conditioning on xi, and then there will be expectation. This is a function of xi and mi. So once I condition on xi, the remaining randomness is respect to mi. So this will be expectation with respect to mi given xi. Okay. So now this is not a function of mi, so it will come out. So only thing becomes this expectation of mi given xi, indicator of mi belongs to k. So this is nothing but the probability that mi belongs to k condition on xi. Okay. So if the xi location is suppose at x, uh, so this will be probability that m mark of point x belongs to k given that there is a point at x. Okay. So let us denote by gxk. So gxk denote the probability that the mark of a point at x belongs to k, given that there is a point at x. Okay, and this is also equal to nu xk. We know that, right? But this is equal to mark distribution, which is can also be computed by integrating the marks probability mark distribution over set k. So once I have that gxk, so remember this term is defined this way. So if I have a point at xi, this will become gxi comma k. So I replace that here. So this become expectation with respect to xi, gxi comma k, indicator xi belongs to k. Okay. Now you look at this. This is a deterministic function fxi. Okay. So what I can do here is I have and again what I do is first I merge this expectation back. So and then conditional and there is xi. So the overall expectation is respect to phi, original phi. So I take this expectation to phi. I sum over all points in phi, and then I have this function as it is. Now this is a function of xi. So I can just write it like fi xi. Okay, this is no longer random. This is just it is no longer random on different marks or anything. This is just function on the point. So this is expectation of summation of functions. So I can apply Campbell theorem, normal Campbell theorem here, which will become the integration of lambda fx dx. Okay, or for non-stationary process, this will become fx into lambda dx. Okay, lambda dx. This is the measure that there is a how many points are there in the set dx. You multiply by this function and you integrate, you get a total summation over the points. Okay, so once I put this, what I get is that Campbell measure is integration of gx dx, and then gsk is nothing but integration of nu x dm over set k. Okay, so what I get is a double integration a cross k of nu x dm and lambda dx. So I take this product and integrate it. So from this, it is clear the density would be nu x in m into lambda x. If I want to compute the Campbell measure of dx cross dm, it will be just nu x dm into lambda dx. Okay, so this this is the total number of points in small interval around x, and this is given that there is a point there. What is the mark distribution? Okay, so this is very intuitive to understand. So if I want to compute how many points are there which are around x and has mark in DM. What I do is I just calculate how many points are there. And because it is a small interval, all the point mark distribution is same. So I just compute that given that there is a point here, what is the probability that the mark will be in DM? And I take that probability and I multiply with the number of points. Okay. So if there are 10 points and there is a 1 by 10 probability that the mark will be in DM, then the probability would be just 10 into, sorry, there are 10 points and then there is a 1 by 10 probability that the mark will be in DM. So basically there will be on the average 1 point, which in this DX set, which will have a mark in DM, which will have its mark in DM.